Welcome to Networks Professionals.
Welcome to The Explainer. Today, we're cutting through the sci-fi myths to uncover how artificial intelligence actually works in our daily lives in 2026. For those of us closely tracking tech development, it is so easy to get caught up in the debate over when, or even if, artificial general intelligence is finally going to arrive. But by focusing so heavily on the horizon, we often miss the sheer staggering scale of what is literally running our world right now. We're moving past the basic discussions and the mainstream hype today to look strictly at the architectural realities of current AI, the systems managing our global supply chains, executing high-frequency algorithmic trading, and dynamically routing our global internet traffic. They aren't science fiction. They are real, they are fully deployed, and honestly, their limitations are just as fascinating as their capabilities.
So, what is the only type of AI that actually exists today? It's a question that completely cuts through the noise. We often interact with systems that feel incredibly expansive, right? Systems that can write code, generate photorealistic images, and debug complex mathematical proofs, all in a single breath. It creates this profound illusion of a generalized, multimodal intelligence. But from an engineering and architectural standpoint, that monolithic intelligence is a total mirage. What we're actually experiencing is often thousands of highly specialized algorithms stacked in a trench coat, seamlessly trading API calls to give you the experience of one unified mind. Despite the massive leaps in compute power and parameter counts, the fundamental category of the technology we build and deploy remains singular. And understanding the structural boundaries of this category is absolutely critical for anyone looking to master the current digital landscape.
Which brings us to Section 1, Meet Artificial Narrow Intelligence. There is a very specific singular term for the reality of the technology we use today. Artificial Narrow Intelligence, or ANI, is widely referred to in academic and engineering circles as weak AI, and it represents the absolute boundary of our current technological era. Now, the term weak AI is famously ironic, because practically speaking, it's anything but weak. In its specific domain, it is mathematically superpowered, but it gets classified as weak because it entirely lacks cognitive flexibility. So the crucial point is that these systems are specifically designed and trained to optimize an exact mathematical objective within a singular task or a very limited range of closely related tasks. They operate within highly constrained vector spaces. For example, a model trained to optimize server load balancing across a global network operates with astoundingly high proficiency, processing millions of variables per second. But it possesses zero capacity to extrapolate that logic to even the most basic distinct task. It doesn't possess fluid intelligence. It possesses immense computational force directed through a very narrow, rigorously defined loss function. Let's break down the exact DNA of this technology in Section 2, the core characteristics of ANI. And this brilliantly illustrates the task-bound nature we're talking about. We have AI systems today, like the descendants of AlphaZero, that are so highly proficient in chess they operate on a level of strategic complexity that completely eclipses the greatest human grandmasters. I mean, they map out millions of branching probability trees in fractions of a second. Yet if you take that exact same architecture with all its massive computational bandwidth and ask it to play a standard game of checkers without entirely retraining it from the ground up, it is completely unable to do it. It fails instantly. This is a classic demonstration of an architectural limitation known as domain adaptation. The system's neural pathways and its carefully adjusted parameter weights are completely locked into the 64 squares and the specific movement rules of chess. Attempting to force the system to learn checkers on top of its chess knowledge would lead to what researchers call catastrophic forgetting, where the new data simply overwrites and destroys the old functional pathways. It is entirely, rigidly task-bound. So let's rhythmically list the 4 core characteristics that define this architecture. First, highly specialized ANI operates perfectly within the strict confines of its training environment. Second, no self-awareness. This is a crucial distinction. When a facial recognition system scans a crowd, it doesn't see faces the way a human does. It processes a massive matrix of pixel weights, analyzing gradients and contrast to find a probabilistic match based on its training data. There's no comprehension, no internal emotional experience, just mathematical optimization. Third, as we just covered, it is task-bound. It entirely lacks the generalized cognitive framework required to transfer learned concepts across completely different domains. And finally, it's intensely data-driven. Its effectiveness relies 100% on the volume and quality of its training data.
These systems use advanced machine learning and deep learning, utilizing gradient descent to minimize errors and identify incredibly complex, high-dimensional patterns that human intuition could just never detect on its own.
Okay, let's dive into this as we move from the theory into concrete, everyday applications in Section 3, Top Examples of ANI Today.
The reality of narrow AI is really best understood not as isolated software, but as the invisible fabric of a modern daily routine. Think about the first 30 minutes of a typical morning. Your sleep tracker triggers an alarm based on a localized expert system analyzing your biometric data to find the absolute optimal point in your sleep cycle. You pick up your phone, and a computer vision model analyzes the infrared dot matrix projected onto your face, running a specialized neural network to securely unlock the device in milliseconds. You open a mapping app to check your commute, relying on dynamic graph routing algorithms that analyze real-time traffic data from thousands of other devices to optimize your path. You start a podcast, and a recommendation engine utilizing collaborative filtering instantly queues up an ad perfectly targeted to your recent purchasing behavior. You ask your virtual assistant to read your messages, relying on a narrow, natural language processing model that converts your audio waveform into text, extracts the intent, and triggers a specific database query. Literally, every single one of these interactions relies on a completely distinct, non-conscious, hyper-specialized narrow AI.
Now, generative AI requires a very specific analysis here, because large language models like GPT-4, Gemini, and Claude often blur the line for us. Because they can hold deep, context-rich conversations across seemingly infinite topics, they mimic generalized intelligence really well. But functionally, underneath the hood, they remain artificial narrow intelligence. They are highly complex stochastic parrots. Utilizing transformer architectures and sophisticated attention mechanisms, they are fundamentally restricted to text-based generation and reasoning within a narrow digital domain. They are basically executing next token prediction. They don't actually comprehend the concepts they're generating. They're calculating the semantic proximity of words within a high-dimensional vector space based on the trillions of data points they ingested during training. Their reasoning is really just a staggering display of parameter manipulation, an illusion of consciousness created by breathtakingly accurate statistical probability. At the end of the day, they are still executing a highly specialized, intensely data-driven task.
Let's shift over to our final section to summarize the ultimate purpose of this tech. Section 4, the silent background operators.
The highest truth of AI in 2026 is that ANI focuses on achieving exceptional accuracy in a single function, operating silently in the background. You see, the ultimate goal of deployed AI is frictionlessness. We don't actually want an emotional, self-aware intelligence managing our automated air traffic control systems, or analyzing our MRI scans, or optimizing the thermal cooling of a massive server farm. No way. We want hyper-accurate, tireless mathematical engines. The lack of generalized intelligence isn't a bug. It is the defining feature that allows these systems to execute singular functions with a level of precision, speed, and scale that biologically limited human operators could never achieve. The most successful AI is the AI that vanishes into the infrastructure, working securely behind layers of APIs to make immensely complex operational tasks happen instantaneously.
So, I'll leave you with this final thought. How many silent, narrow operators have you relied on today? By recognizing these systems for what they truly are, highly specialized mathematical engines and optimization algorithms, rather than conscious entities, we fundamentally shift our perspective. We stop viewing AI as a monolithic magic trick and start understanding it as a structural tool. Grasping the boundaries, the data dependencies, and the sheer computational power of artificial narrow intelligence turns us from passive consumers of technology into active, informed architects of our own digital lives. Thank you so much for joining me to break this down. Keep analyzing the systems around you, and I'll see you in the next explainer.
Thanks for watching.